Assalamu alaikum. Bismillahirrahmanirrahim. This is Muhammad Ejaz, your power plant engineering course teacher, practical experiment teacher. Well, before starting of this lecture, I will just give you a brief description or just introduction of me. As you know, some of the experiment have been covered by Adil Saab, and some of experiment will be covered by me. That included experiment number 9, 11, and 1, 2, 3. So from practical number 4 to onwards have been already covered by Adil Saab. So I'm just starting from lecture number 9, and after that I just have one lecture more in this series, experiment number 11. Then we will start from 1 to 3. Okay, so before starting of this, Michael, I just give you some uh, some of the details. So you know me. Well, I've done mechanical engineering from the same institute, Kennedy University, in back 2012. Then I done my master's from NUS University in thermal power energy. Then started my career from General Tire as a trainee engineer. Then I will permanent employee over there as a utility engineer, looking after whole operation maintenance of their utilities department, including their generator, Cummins generator, CAT generators, Caterpillar generators, and they have three boilers like 65 ton, 22 ton, and 12 ton. So they are large consumption of steam for the curing of the tires. Okay, so and many compressors, pumps, and turbines, etc. So being engineer over there, I was looking after whole operation maintenance, and above me I just have a manager, and then above directors of the companies. So it's a good experience learning the whole plant operation, and as well as they are expanding, so we have an opportunity to expand their facility. So we have installed LPG and CNG plant around 65 MMBTU, and as well as new boilers including 200 million boiler. That project cost around 200 million rupees. So it's a big project. Then alhamdulillah, I've done this project and gain experience. Similarly, then I switched towards English Biscuit Private Limited as a utility executive. They have more or less same facility as compared to General Tire, but they have an addition that it is completely air conditioned facility, central air conditioned facility. So they have a big HVAC plant. So I'm looking after whole their operation maintenance of HVAC plants and power generation. That include 1,000 ton of chilling, 1,000 ton of chilling, 500 ton chiller, and remaining 200 and 100 chiller. And all the utilities like compressed air, the compressors, boilers, pumps, and also they have owned their captive power. So they have gas generator around 1 megawatt of 3. So they have 3 megawatt power generation facility, and as well as they are also expanding. So I have experience of erection of whole 3 megawatt power generation plant. It also cost around 200 million rupees. So it's also big project, and alhamdulillah I've gained experience from that. Then I switched toward Kennedy University as a lecturer, and from last 3 years, 3.5 years I've been there as a lecturer. And also, so I'm interested in some of research that have I just explored in my industrial experience. So whatever thesis I have in masters, I just published one paper from that, and one from my own from my own interest. Like I've designed river turbine, floating river turbine. Still I'm doing working on it, and working on its commercialization. Three more project papers have been published. This is old presentation. One in international conference in Saudi Arabia. That will be in 23 to 25 February. I will be going there for their presentation, and that paper will also publish in journal paper. And two paper modes related to similar project. One is river turbine, and another one is geothermal cooling. Anyway, I also have some membership accreditation, etc. So let's come towards experiment number 9. Well, experiment number 9 is related to ejector. Working on the ejector bench, investigation of the efficiencies of the ejector bench. What is ejector? By a simple word, it means that it ejects something. But ejecting, it uses the phenomena of suction, and by the how they are suction, by using the high velocity of steam, the principle by the principle of entrainment. For an example, if we have a high velocity steam passing over the pipes, due to the high velocity, the surrounding air also pushed by this high velocity stream. So the if the air present here he is sucked by this or moved to with this medium, so the remaining portion become vacuum. It's become vacant. So when it become vacant, so if we have a hole like this, the incoming air will come over this place. So definitely, so we have if we have a high velocity stream, it producing a circulation or vacuum surrounding it, that will be utilized here as a ejector of the water. They have not only water, they have many application in power generation and in mechanical engineering field. uh, Very commonly or basic general application you might seen in your in what can I say, जो तवा लगा मतलब जो तंदूर, yes, in tandoor we have let's come towards the writing. Yes, in tandoor you see that there's a stove inside, and the roti place over here. So here how the air is, the phenomena of combustion, you need around 14:1, meaning 14 part air and 1 part of air fuel. So you can see that fuel is going toward this and the flame is burning in the bottom. So how it is burning if there is no passage of air, because it has one hole, and that hot air goes above, so there no place for pushing the enough amount of air for the combustion. So you see that there in the pipe we have a ejector. If you see the closely, you see that one nozzle, and the shape is like this. So when the gas is passing from this nozzle, it producing velocity due to the nozzle effect, and due to the high velocity, the air present here it's moved with this natural gas. So it mixes here and then goes to there, and the burning is happening. Another example, like emergency in the airplane, we have an emergency air filled up states. So the compressed air filled this air, but the compressed air not in a very large quantity to fill whole this their state. So we have also have this kind of venturi. So some is compressed air will fill, and some surrounding air will also goes into this place. So it filled whole elevators, air cushion elevators, etc. In another example in condenser. Like in condenser, if we rub the hole, like in condenser, when the steam is coming in condenser, you see that in the steam table, after turbine, the steam is coming over here. So it is in the saturated liquid vapor. So we can utilize some of the vapor by using a nozzle over here with the high velocity steam. It produce vacuum, so it sucks some of the flash steam with the steam, and then this steam utilized in some other process of heating or reheat to again to turbine section, or low pressure turbine can be go towards the low pressure turbine. So it have many application. The principle is same. We have a high velocity of stream that produces suction around it, and that any medium can be sucked by it, whether it is a water, gas, liquid or gas, anything except solids. Okay, now come towards the bench. In this case, how we are producing it? Well, Before this is basically this is basically schematic of working bench. We have a steam supply over here from the electrical boiler that covered in the previous experiments. So around 4 to 5 bar, whatever you set the pressure, the steam coming over here. In this section we have a ejector, we have a converging divergent nozzle. Okay, we are producing supersonic velocity of with the help of high pressure steam over here that produces suction. And in this suction tank S1 we have filled with water. We have flow meter to gauge how much the water is flowing in the suction tank. So water is flowing in the suction tank, and this pipe suck the water and mixes with the steam and goes toward the delivery tank. So in this experiment, we're just noting the flow rate of the water and the flow rate going towards the delivery tank, their temperature, pressure. So in this experiment, we have two applications like pumping. We are pumping water from one point to another. Another application is heating. We are heating the water with the steam and mixing with the steam, so hot water comes into the delivery tank. Okay. So I just show you the physical. This is physical picture of steam. In this section we have a steam. So this is steam pressure. This is basically, it is covered by this. In this section we have high velocity nozzle, converging divergent nozzle, that will be shown in the in your workbook. This is flow rate, volume flow rate, water flow rate apparatus. This is section S1 tank, this is S2 tank. This is calibrated centimeter mark that calculated the height of the tank, and by some correction factor we multiply by with correction factor, we get the volume. So basically this is the section 10, this is the delivery tank. These are the gate valve to open steam and to open the water from the delivery tank to adjust their flow. Okay. In this experiment we set some level of water, and when we open the nozzle, the amount of water sucked from this tank will be delivered from that tank. After some in observation we are calculating the volume flow rate of discharge tank. So in suction tank we only have a incoming water, but the discharge tank we also have a mass of incoming steam, because steam is mixed with the water. So this is the calculation, simple calculation. By using this simple calculation we calculate the efficiencies of nozzles, and if we suppose as a heater, then we calculate as a heater. Okay, now these are the parameters. MW represent over here. MW is the mass flow rate of water, duration of the test. MS the mass flow rate of the steam. CP is specific heat of water, that is 4.18. Enthalpy of saturated liquid HF, that will be calculated from the steam table. Hg is enthalpy of saturated vapor. HFG is the it's again enthalpy of the mixture. Q is the quality. PS is saturation pressure of the steam. TS saturation temperature of steam. T1 temperature of water supplied on the ejector, and T2 is the delivery of the temperature of water delivery by ejector. J is the acceleration due to gravity. Okay, I just solve this experiment with some sample calculation, and will send another video regarding the whole observation. In that video we are observing their pressure, temperature, and the observation column. So what you have to do the calculation of these observation, which will be given in later video. In this video I just give you brief about the calculation, and give the one calculation, sample calculation, out of which you have to you have to do your calculation with the given observation in the video. Okay, so in this experiment, if we zoom out the ejector shape is like this. Okay, the steam is coming over here. Steam is coming over here. First, we have a converging nozzle that the flow of steam is subsonic. So this converging act as a nozzle. It increases the velocity, and it because we have a very high pressure around 7 to 8 bar and have a very small area. So if we further reduce that area, we can goes up to the sonic velocity. Okay, so when it goes to the sound throat, it comes to the sonic velocity, and after that this converging will not work as a nozzle, so we have to put diffuser over here. Now the diffuser will now work as a nozzle too. Divergent section, not a diffuser. Diffuser used to increase the pressure and decrease the velocity. This is converging section, increase the velocity as a work as a nozzle, and a throat we got around sonic velocity. What is sonic velocity? The speed of the steam is equal to the speed of sound. Okay, we also have some sonic boom over here. After that, divergent nozzle, divergent section, this will also act as a nozzle. So from this we have a very high velocity, around supersonic velocity of steam, and due to the high velocity, the surrounding portion air is sucked by this high velocity steam and goes over here. So when this air goes over here, this become produce a vacuum, and due to the vacuum, the water will lift, and when the water is lift, it mixes with the steam, high velocity steam. Liquid water have a very low velocity due to the vacuum, and it is a very high velocity. When it mix, it becomes subsonic again. So then the subsonic medium goes over here. Now you can see that we have a divergent section. Now if we have a subsonic velocity, the divergent section work as a diffuser, and diffuser used to increase the pressure, not velocity. So we have some velocity, subsonic velocity, but now we ought to convert this velocity into pressure. That is a purpose of the pump. So we need to use increase enough pressure so it can moves from this point to this and overcome the resistance in the pipe. If we not produce enough pressure to overcome this resistance, the water will not flow. Okay, it choke, and steam just some of the steam will go, it not work completely. So we have to increase the pressure to overcome the resistance or pipe, or if we want to put this water into some at higher level, we also need to increase the pressure. Okay, so now the diffuser worked as a divergent section as a diffuser, and increase the velocity. So out of that, we have a from zero pressure to at some pressure, we are increase water, we are suck water with suction effect and increase its pressure and move towards into the delivery time. Okay, so now come towards the this video. We have video regarding it. So some first pressure is injector steam pressure. You can see that we have a 3 bar pressure. In this we have a injection pressure. Okay, this is zero pressure and this is minus 0.4 bar, and this is delivery tank, and we have delivery tank pressure. Yes, it's around 0.1 bar. Okay, these are the observation you have to write on your book and do the calculation. I will not do the calculation with this observation. This is for you. I use some sample calculation and do some calculation. This knob will tell the temperature of the steam. The steam temperature is around 120. तो डिलीवरी टाइम में ये आप देख सकते हैं 40 डिलीवरी टाइम वी हैव अ टेम्परेचर लाइक 47. I just write observation in the book. Okay, so we are going to start the experiment. This is flow meter. The water is coming from this side. This is in the liter per second. Sorry, liter per minute. Okay. We have set that kind of flow, so it maintains the level in this tank, not decrease, not rise. If we open this wall more, this tank will level will reduce, and if we choke this walls at some level, it will overflow. So we ought to make such arrangements so the water level becomes constant, and how much the water is coming over here is exactly going towards the next tank, and the level will almost same. These are the observation column which I will uh, this video I will give you in later. From this video you have to do calculation. Now suppose that we have taken all the observation from this experiment. You can see that we have to know the pressure, temperature. Uh, 1 second. We have to we have to create the pressure, supply steam, the suction pressure and discharge pressure. Similarly, the tank 1 pressure, the tank 2 pressure, and the steam inlet pressure. Okay. Now this is the water flow rate, and from this tank we have a marking out of which we have to observe the level. Okay, now do the sample calculation. In this I will give this observation video. So you will just take this reading in your workbook and do the calculation. Now take some sample calculation. I just where is that sample calculation? Okay. Yes. So let's suppose this is the sample observation. We start with the time 2, but in your observation take time after 2 second 2 minutes. Okay, so this is initial. You can see that you can take it as initial calculation, and you just start from the 2 minutes to 4 minutes, because in the video which I just are showing, it start from 2 minutes. Okay, so in this sample calculation we have a steam pressure 2 bar, and it maintain 2 bar pressure. Steam temperature almost 141, 139. There's a little deviation. Flow rate, we set the flow rate of the water to 9 liter per minute. The temperature of tank 1 is 35, and the level in centimeter, the centimeter level is 37.7. Just steel line you just have shown in the video. In the section we have a minus 0.4 pressure. You can also see that the similar pressure is in the video which I have shown in just recent video which I was playing. We have a minus 0.4 bar pressure. It is a suction pressure. It is high velocity stream is producing vacuum. and the delivery temperature is 45, so it increased temperature from 35 to 45 with the mixture of steam. Now the tank level 2, in first level we have a 15 second, and after 120 second, like 2 minutes, we have a level of like 35 minutes, the same level as compared to almost in tank 1. And the pressure had discharge pressure have value of 0.1 bar. That also have, we also have a 0.1 bar or 0.4 bar. You will see the video and observation columns. Okay, now do some calculation regarding its efficiency. The tank calibration is 0.958 liter per centimeter. So if you multiply by this centimeter 37 with 0.958, the centimeter cancel out, you get the value of liters. Okay, so from the tank level you can note that how much the water is present in the tank, and dividing by with the time you can find out its water flow rate. Okay, the dryness fraction steam, you already done a numerical experiment of the dryness fraction. In the current boiler have a dryness fraction around 0.94, that is the quality of steam, also known as quality. The barometric pressure of Karachi is 1 bar. You already know it's sea level. Density of suction pressure of temperature T1. The density of water is around 1000, but it has some variance with the temperature. So at initial 35 degrees centigrade we have a density 0.994, and from that 45 we have a density of water is 0.990. Okay, kg per liter. You can take this value the net as well, the chart of different density per centimeter, gram per centimeter cube, or if you convert kg per liter, whatever the decimal is around the same. So you can see that we have 48.998 and 35 is 0.995. so you can take from you can google these values too as per your observation readings. Anyway, going towards sample calculation. Yes, this is the sample calculation. This is the formula. This formula is already available in your workbook. You can see from this. This is energy supplied, simple ms and hf plus qhfg, or in thermodynamics you learn hf plus xhfg. The quality of steam here denoted by the q. In your courses it is denoted by x. Okay, the pumping energy added to the water, simple mass flow rate multiplied by the pressure difference divided by the density of water. And thermal energy added is simple, can be calculated with the mcp delta t, and also can be calculated with mcp mcp of mcpt, sorry, the enthalpy of the steam, and the enthalpy of the steam with the mass flow rate. Okay, now comes towards, these are the efficiencies formula. In the efficiencies, the overall efficiencies, the thermal energy added to the water, energy, no, this is overall thermal energy added to water, pump energy, and energy of condensed steam. This is the overall efficiencies. And energy supplied is simple, is in energy of the steam, that is ms hfg hf plus x hfg. The energy added to the water, simple mcp delta t. The pump energy, thermal energy, sorry, pump energy is pressure rise multiplied by mass flow rate into divide by density. And energy of condensed steam in simple mcp t2. Okay, the condensed steam is the water, so that way we take mcp t2. But we can also calculate this condensed steam with the hfg, m multiplied by hfg or h of the water. Anyway, now come towards the calculation. Yes, this is the calculation. First we will calculate mass of water. The formula is density, that is 0.994 kg per liter. Okay, this is the kg per liter. Multiply water supply flow, the water coming from the initial line, and the volume taken from the suction tank, and we just take these two average. Okay, so water is supplying the flow meter. You see that liquid flow meter. Oh no. Yes, so this is a 9 liter per second. We have taken water flow rate from this, and another the level of this, that how much water coming over here and going towards the net section. So we take this average value in the calculation. What is going? This is the density of the water. Now this is water flow rate. Okay, so we get kg per liter. Now we have a volume, so multiply by the density, we get the unit of kg per minute. Right now in this we have a unit of liter per minute, so multiply by with the density, liter will cancel out and the kg will remain. Okay, so this is 9 liter per minute. 0.958 is the again the 9.958 is the correction factor that have been discussed in the observation column. By multiply by this this is volume taken from the suction tank is 37.7 initial, and after that we have a level 37. Okay, in 2 minutes. This is the flow rate of the 2 minutes. Okay, so we take minus this reading, that the difference of this reading will show the actual change in the water quantity. Okay, multiply by the correction factor, we get the with the unit of centimeter, we get the unit of liters. Okay, divided by 2. Okay, now this means that in 2 minutes how much the volume is transferred from one tank to another tank. So we add with the volume flow rate which coming from the initial pipe. We are also discharging the water. Okay, now add these two values and multiply with the density, we get the value of kg per minute, mass flow rate. Okay, similarly in the discharge rate, we take the reading of we take the reading of initial in the discharge tank. You see that the discharge tank in the this is the observation column. Okay, in first tank we have a reading 37. Okay, initial 37, and after that we have a 37, so we just minus this 2 point and divide by 2. And the discharge level, we already have a level of 15, and after filling of water from one tank to 2 minutes, in 2 minutes we get the value of around 35. So in the again in delivery rate, we just subtract this value, divide by 2, multiply by its correction factor, so we get the value of in the liter per minute. Okay, this is the centimeter. After multiply by correction factor, we get liter per minute. Multiply by density, we get the value of kg per minute. Okay, now we can from these two value, this is the initial value water incoming from the line and going from tank 1 to, and this is the tank 2 value. So in the tank 2 we have this water as well as some steam mixed with this water. So in tank 2 we have more mass flow rate. Okay, so this is 9.77 and minus 2, and by minusing these 2 point values we get the mass flow rate of steam, that is 0.4337 kg per minute. Okay, now energy supplied to the steam is simple formula, m multiplied by enthalpy. Okay, so the energy, the steam is coming from the boiler, is not superheated, not saturated liquid, it is a mixture of liquid vapor. Okay, and have a quality of around 0.94. So multiply by mass flow rate multiplied by hf plus x hfg. So it's x, the x is denoted by q here is, so 0.94 is the quality multiplied by hfg, that has taken from the steam table 2164. Okay, and hf is a saturated liquid value, that is 5.61. so we get the value of energy supplied in 19.4 kilowatt. Okay, now you can also calculate this value, check this value from the steam table. I also open the steam table graph over here. Yes, in 2 bar we have a 2 bar, 2 bar means we have a 200 kilopascal of the pressure. Yes, the value in the kilopascal, so we add with the, this is that is a gauge pressure, and here we have a total pressure. So 1 bar is atmospheric pressure, so adding with 2 bar 3 bar, so we have to check this value in 300 kilopascal. So 300 kilopascal, you see the hf is 561, no, so hf is here in 300 we have 561, and you see that hfg value is 2163, 2164 we just. Okay, we take these two values over here and calculate the energy supply. Okay, now come towards energy added to the water. It's simple, mass flow mcp delta t, mass of water, that is divided by, we just divide this value with the 60 to get in kilowatts. Okay, we have kilo, we also divide this value with the 60, so we get kilowatt, because we have a flow in kg per minute, so we have to do is kg per second, in set kg per second to get the value of kilowatt. Okay, now we also divide with this value with 60 to get kg per second, multiply by cp, that initial given in your workbook 4.18, multiply by this temperature difference, 45 minus 35, this is the delivery tank temperature, this is initial tank temperature. Now we get the enthalpy added to water is 6.47. Now comes toward the pump energy. Pump energy simple, mass flow rate multiplied by pressure difference divided by density. Mass flow rate is this, this is a pressure, discharge pressure 0.1, and the suction pressure is minus 0.4, so this will become minus plus, and we convert this bar into pascal to get the value of kilowatt. Okay, we multiply by this, divide by 60 to get in the kg per second, divide by density of the water, and divide by 1000 to get the value in kilowatt. Okay, from this we get the value of watt, so we divide by this with 1000 to get the value, but here we already taken this value in the cp in kilo form, so that's why we get the answer in kilowatt. Okay, now enthalpy of the condensing steam we can calculate with the two formula, mcp T2 and direct mass flow rate multiplied by enthalpy of the HF, that is saturated liquid. So you can also check this value from the steam table. At 35 degrees and we have HF 146 multiplied by mass flow rate of steam in kg per second divided by 60 to get kg per second. Now we get 0.104, 1.08 kilowatt. This is the this is the enthalpy of the steam which condense and mix with the water. This is from this formula, this is cp given in the paper, and this is mass flow rate and multiplied by temperature, you get the same formula. Okay, now you get the overall efficiency, energy, enthalpy added to the water, that is 6.47, pump energy, that is around pump energy 7.78, and the enthalpy of condensed steam is 0.108 divided by the supply steam that has been calculated in previous page 19.4 4. So by using this formula we got the efficiency of 79. Okay, now later calculation you can do yourself. If we just calculate the pump energy, simply divide 7.7 with the 19.4, and if we take the time considered application as a heater, add this two values 6.47, 1.0 and divide by 19.4, you get the efficiency. So now I've done some sample calculation. I'm giving you the observation videos and the observation column picture. Do your calculation in your workbooks and submit at time when the time required. Okay, thank you. Khuda Hafiz.